Hi, today we want to learn what is an asymptote. What is it? An asymptote is an imaginary line where the function approaches but never touches it. Like this. Can you see it there? Let's get a zoom here. It separates the red line, that is the function, of the axis, the x-axis in this specific case, and never touch it. Some famous asymptotes is 1 divided by x. Here you can find an asymptote in y equals 0 and x equals 0. E to the x is another famous asymptote. You're going to find that this function, e to the x, never touches 0, so you have an asymptote in y equals 0. Another one is a trigonometric function, tangent of x, that has an asymptote in y equal n pi divided by 2, and you're never going to have a function here. Some common asymptotes, 1 divided by x, yes, it's not just as famous, it's very common. Again, you have an asymptote here in x equals 2 and y equals 0. And 1 divided by x squared plus 7x plus 12. Here is different because we can find two asymptotes in x minus 3 and x minus 4, and one asymptote in y, that is y equals 0. But what is in common with these two equations? 1 divided by x and 1 divided by x squared plus 7x plus 2. Can you guess? Yeah, they are rational functions. P of x divided by q of x. We can find two kinds of asymptotes. Vertical asymptotes are related with the x-axis and is related with the denominator of the function. Vertical asymptotes related with the denominator of the function. We have another ones. The vertical asymptotes and the horizontal asymptotes are related with the y-axis and is related with the degree of the polynomial. Do you remember what is the degree of the polynomial? The maximum exponent where the polynomial is raised to. How we can get a vertical asymptote? It's very easy. Just set the denominator, here is a mistake, it's denominator to 0 and solve the equation. If you have a linear equation, you can isolate it. If you have a quadratic equation, you can use general formula. If you have a cubic equation, you can use the residual theorem or another method that you know to get the zeros. So, once that you solve your equation, you have your vertical asymptotes. How we can get a horizontal asymptote? Here we have three rules. If the degree of P is bigger than the degree of Q, you don't have asymptotes. If the degree of P is equal the degree of Q, asymptotes in Y is given by A divided by B. And what is A and what is B? Is the main coefficient. Remember, the main coefficient is the coefficient that it's belong to the highest raised term on your polynomial. And the last one, if P of x, if the degree of P is lesser than Q of x, or the denominator, your asymptote is equal y0. In another course, maybe you're going to know that if you only have 1 degree of difference between P and Q, maybe this is not true, but maybe it's true. But maybe you can have another kind of vertical or horizontal or oblique asymptotes. Let's see an example. Our function is 1 divided by x squared plus x minus 6. And we can recognize it is a rational function. That means that we can have asymptotes. In this case, we can analyze the denominator, and it's a 2 degree, second degree denominator. Then we're going to get two asymptotes. Let's remember how to get vertical asymptotes. Just take your denominator and equal 0 here. Then we can solve it using general formula, and I have x equal minus 3 and x equal 2. That means that x equal minus 3 and x equal 2 are my vertical asymptotes. Now let's try with the horizontal ones. How to get horizontal asymptotes? We have the same function, 1 divided by x squared plus x minus 6. And remember, horizontal asymptotes are related with the degrees of the different polynomials. Let's see what happened here. In numerator, my degree is 0 because I don't have a variable. I don't have nothing raised to anyone. And in the denominator, my degree is 2. And you clearly know that my degree is 2 because the highest exponent in the denominator is 2. Then, where are my asymptotes? We can notice here that p of x is lesser than q of x. And remember, we have rules. Let's see our rules. If p of x is lesser than q of x, your asymptote is equal y equals 0. Then, that's what I have. Y equals 0. Let's see how the graph looks like. Well, here you can identify an asymptote in x equal 2, an asymptote in x equal negative 3, and the asymptote in y equals 0. That means that this graph never going to touch x-axis, that is the position of y equals 0. Okay, I hope this little video will be useful for learning how to get asymptotes. See you next time.